Hey there! Welcome to my channel Beyond the Graph, the place where numbers tell stories and letters make sense. Today we're tackling a question that's puzzled a lot of people. Why is 0.9 repeating actually 1? That's right, I'm talking about the repeating decimal 0.9999, where the nines go on forever. It sounds a bit strange at first, but stick with me and you'll see actually that it is true. So let's break it down together. Let's start by defining 0.9 repeating as the number we're working with. This means we have a decimal that goes on forever with nines after the decimal point. So 0.999, let's say 9, is the same thing as 0.9 repeating. Now you might be thinking, it's just really close to 1, but it can't be exactly 1, right? Well, let's see if we can actually prove it to be 1. First, let's make things easy by calling this thing right here, 0.9 repeating, something simpler. We'll say x be 0.9 repeating. This is just a label for our repeating decimal. Now let's multiply both our sides of this equation by 10. So 10x equals 9.9 repeating. Next, the magic happens. Let's subtract the original x from the equation. We have 10x minus x equals 9.9 repeating minus the x, and the x was the original 0.9 repeating, so we can do minus 0.9 repeating. Notice that on the right side the repeating decimals cancel out and we're left with 9x equals 9, and we can just put point, but it doesn't really matter, it's the same thing as 9. And now we can solve for x. This is basic algebra. We can just take 9x equal 9 point and divide everything by 9. Here we get x equals, what do we have? 9 divided by 9. It's 1. So there we have it. Since we started with x equals 0.9 repeating and ended up with x equals 1, we've shown that 0.9 repeating actually equals to 1. It's a little mind-blowing, but mathematically they are exactly the same number. But still, if you are a little concerned about the proof, I'll show you a different one. Alright, now let's take a completely different approach. And this time we're going to use limits to prove that 0.9 repeating actually equals 1. This method involves looking at how 0.9 repeating behaves as we get closer and closer to 1, by adding more and more nines after the decimal point. First, let's express 0.9 repeating as an infinite sum. 0.9 repeating equals 0.9 plus 0.09 plus 0.009, and so on and so forth. This is an infinite geometric series where each term is 1/10 of the previous term. Now we can say that it is S. This is a geometric series with the first term, a, and a common ratio of 0.1. The sum of infinite geometric series is given by the formula S equals a divided by 1 minus r, where a is the first term and r is a common ratio, or the common ratio. Now let's plug in our values. S equals the common value 0.9 divided by or over 1, which is part of the formula, minus 0.1, which is the common ratio. This gives us 0.9 over 1 minus 0.1. Hold up, what is 1 minus 0.1? It's 0.9, right? So the sum of infinite series is equal to 1. This means that 0.9 repeating actually equal to 1. Both proofs, the first one and the second one, both show that 0.9 repeating is exactly equal to 1. It's a great example of how math can sometimes be a little concerning, but always beautiful once you understand the reasoning. Thanks for watching, and if you like this, don't forget to like and subscribe for more math mysteries.